let's try to calculate or let's try to determine Young's modulus in an experimental way. Okay, now for this one, see, this is the experimental setup. Now let me explain what this is. See, you have two wires, A, B. Now A is called a reference wire and B is called experimental wire. Alright, now these are the two wires. Next, if you look at it, near the reference wire, okay, near the reference wire, you have a meter scale M, okay, or it is also called as main scale, alright, M. So you have markings. Next to it, you have another one called as vernier scale, which is called V, okay, or represented by V, alright. Now, this is the experimental setup. At the bottom of these two, you have plates, where you can put weights and, check it out. Now, what we are going to do in this, it's a very simple experiment. Okay. Now, in the reference wire, so you see a plate, correct? In that plate, we are going to put some weight. Okay. We are going to put some weight. And also in the experimental wire, what we'll do, we'll start putting more and more weight. Okay. More and more weight. In the sense, weight in the sense you are going to put some mass, correct? Which applies some force. That's why in normal terms, you can say that we are putting weight, a force basically. Alright. Now what happens? The experimental wire is going to stretch. Correct? Now why does it stretch? Because there is some force. And because of the force, there is a tensile stress which is being applied on the wire. Isn't it? You have a tensile stress. Now what is going to happen? See that vernier scale and meter scale. Now you have a pointer, correct? That arrow mark. That pointer is going to shift. Once the pointer shifts, then what happens? You can figure out what is the change in the length, correct? Isn't it? Now what you have? You have the tensile stress, correct? Then tensile stress is what? Force applied per area, correct? Or you can say force, which is here the load extension, isn't it? The force divided by area of cross section. Now, how do we calculate the force? Force is basically weight. So, F is equal to M into G. Correct? Then next thing what you have? You have area of cross section. Area of cross section is what? Pi r square. Isn't it? Now, r is the what? R is the radius of that particular wire. Pi r square is the area. Correct? Next, what you have? Because of the tensile stress, there is longitudinal strain. Isn't it? That increase in the length is what? Delta L. Correct? And original length is L. Correct? You have longitudinal strain delta L divided by L. Correct? Now, how do we calculate the Young's modulus? Young's modulus is what? Stress divided by strain. You can also call it as the tensile stress or normal stress divided by longitudinal strain. Correct? Apply this particular value. In the numerator, you have mg divided by pi r square whole over delta L divided by L. Isn't it? Now, if you take it, you're going to get y is equal to mgl divided by pi r square into delta L. Now, if you look at this particular formula, everything is known, isn't it? Now, m is what? That mass, whatever you are inserting or whatever you are putting on the plate, which is connected to the experimental wire. That is m. You can put maybe 10 grams or 15 grams, or whatever it is. You are going to put some weight to it, correct? So, some mass to it, to be more precise. G, you know. Original length, you know. Correct? And pi, of course, it's constant. Radius, you know. You figured out the delta L value. Once you do this one, you can calculate the Young's modulus for a particular material. So how much it can stress or how much of stress the particular body can take. What is the extension? Okay, now when you're doing these things, guys, it's very important to understand why we have to determine it practically. okay, or experimentally. If you look at it, most of the things what you see, like, big buildings and, very famous bridges, or so most of these, heavy machineries, here this Young's modulus or modulus of elasticity plays a very, very important part. When I say very important, I'm talking about the safety of buildings, safety of a bridge, and how much of weight or mass, a crane can lift, how much of load it can lift. Now, what you're going to learn in couple of the next couple of videos is about application of this elasticity, where you're going to use it practically, and then you will understand why this experiment is necessary. Understood? So remember, if you know the length, mass, and extension of length, you can figure out the Young's modulus in the experimental way. Alright, so this is what this particular video is about. Experimentally, how you are going to determine the Young's modulus.